Right, everybody, welcome to the Proteus Insights and Recommendations webinar. So, see some familiar names and faces already. Juan Pablo, what's up, man? So I'm going to just jump right in. We're recording this, so anyone who doesn't catch this at the beginning, you'll have a chance to kind of backtrack. So what we're doing here is first I'm going to go over a little bit of the background on this feature that we developed, kind of the science behind it. Mainly going to be talking about strength, speed, and power, how this relates to the force velocity curve and the problems Proteus is solving for, and how this new insights and recommendations feature solves that problem. Then I actually want to go into the demo of the feature itself. I want to show you how to set the filters correctly, how to read the visuals. We're going to go into the recommendation section and kind of what's in there. And then I'll also kind of show you how the new test results screen functions, and also going to tease a little bit on the upcoming sharing function that we'll be adding to this feature. And then lastly, we're going to go into what we would recommend as far as testing frequency and test selection. Okay, so first off, let's just jump into some of the basic science. So, I think probably everyone on this call knows the difference between these things, but just to cover everything, cover all our bases here, what's the difference between strength, speed, and power, right? Well, strength is how much force you can reduce, speed is how fast you can move, and power is a combination of that force and speed, right? And so what we know is with heavier loads, if we look at the force velocity curve, the slower you move, right? And with lighter loads, the faster you can move. And power is optimized somewhere in the middle, depending on the research you look at, depending on the movements you're looking at, it's anywhere from 30 to 80% of that maximum load or maximum force that you can produce. So when you think about this, and you think about the problem that exists, we all train a lot of different types of athletes. And of course, different sports have different needs along the force velocity spectrum, but also we have different positions within different sports. And I'm going to have to shout out the Georgia Bulldogs, of course. So going to get a lot of Georgia stuff in here. But even different positions in different sport or in the same sport have different needs across the force velocity spectrum and across different body areas. And then even different movements in the same position in the same sport have, different needs across the force velocity spectrum, right? So, how do we train this? Where do we train? Where do we load people along the force velocity spectrum? Do they need strength, power, or speed? And solving that problem is obviously very complex. And the real issue is if you don't kind of respect this entire spectrum, and you only focus, say, on just strength, what you can end up doing is creating an undesirable outcome in their training. So let's just say you did strength training only. So your original, force velocity curve was this kind of dotted line here. If you strength train that individual only, you're going to make a positive change on the force velocity curve, but only on the high force, low velocity side of things. And you might actually make them slower and less powerful on the bottom side of this curve, so with lighter loads. So you really need a correct mix of loads in training and speeds to achieve the best outcome. And that's what we're trying to solve. But there just hasn't been an easy and efficient way to measure strength and speed across the entire body, especially with multiplanar movements. And so obviously that's what Proteus is trying to do. And if you were trying to do this without Proteus, this is just an example of all the different stuff you probably need to be able to do what we've done with this new feature, right? You would need multiple pieces of equipment. You would need, racks, maybe Kaiser machines, med balls. Some of the people on this call I know have a lot of this information or a lot of this stuff, but you'd also need measurement capabilities. You need something like a perch or force plate, or even a good old-fashioned tape measure to measure how far you throw said med ball. You'd have to record it all down, write all these numbers down in spreadsheets or however you want to do it. And then probably the hardest part of this, if you were to do this manually, is you have to find what norms exist for each sport, for each movement, for each cohort that you're working with, whether that's certain age ranges, certain positions in sports. And some of that information doesn't even exist. So if you were to really look at the problem here, or look at trying to do this for each athlete, we're talking 2 to 3 hours max for the type of assessments that we have now condensed down into as little as 5 minutes. So with this feature, you're obviously, you know, as everyone knows here, your Proteus is trying to solve this by combining this testing and 3D resistance capability to give the ability to measure physical strength and speed across the entire body. So in less than 5 minutes, you'll test planes of movements, all kinds of in different planes, different exercises. You'll compare to an individual for their norm of age, sex, and sport. You'll know which body areas need the most attention. You'll understand where they fall along this force velocity curve. And then we're actually going to give you actionable exercises that you can do that we suggest, that you basically a selection along the force velocity curve for that particular movement on how they should train. And then lastly, you're going to be able to track that progress. So you'll first perform the test. You'll know exactly, you know, which body areas need the most attention, right? Then we'll immediately jump into being able to compare an individual for their norm, for their age, sex, and sport. I'll show you how to set these filters appropriately and what to do if you run into a low sample size. Then you're going to be able to actually see where they fall in the force velocity spectrum. We're going to then actually give you exercise suggestions based on that. And then you're going to be able to track that for each individual. And then we're going to give you a whole library of tests that you can do this from. I'll also kind of give you a kind of a preview, or I guess kind of talk to you guys a little bit about how we're going to be sharing this in the future. So right now, as the feature stands today, there isn't going to be a share button available. But when that comes out, when you're done with a test, you'll be able to hit that share button, and then you'll be able to email to the trainer that's logged in, the client that's logged in, or you'll be able to put in any email for anybody that you want to send this to. So it could be a coach, a physical therapist, a doctor, a parent, whoever you want to send it to, you'll be able to send it immediately from the kiosk itself. And everything I'm showing you here, you'll also be able to do from the website. So really the value here, though, is in our database, right? What we're really trying to focus on here, and why it's important that everyone puts in their demographic information and for each of the athletes and clients they're working with, is because we're building this normative database on total body strength and speed. And we're measuring this on traditional movements, vertical jumps, you know, push-pull movements, things like that. But we're also measuring on completely new movements that just haven't been easily be able to collect before. So that's these multiplanar and full body movements for the first time ever. And then we're obviously, from that information in that database, we're able to give you an idea of training needs across the body area for the first time ever. So, okay, kind of now let's like jump in a little bit to what this actually looks like, okay? So if we take a look here, this is kind of how this is our analysis criteria for how we classify performance and movements. So every movement that's done on an insights generating test gets bucketed into its own movement category, and that movement category gets assessed on your performance in power and acceleration, and gets compared to be put in one of 4 classifications, either low strength, speed dominant, strength dominant, or balance of high strength and speed. So if a movement gets categorized as low strength, basically the criteria for that is if you're below the 50th percentile for your cohort, for whatever that cohort may be, if you're below the 50th percentile, then we automatically put you in the low strength category. And the implication there is you need to train high resistance, low velocity movements, okay? So just keep that in mind. If your power percentile is above 50th percentile, right? So that's this line here. Anything above that, we're saying, okay, now let's look at the difference between your power and your acceleration to determine which one you need to focus on. So if your power is greater than 5 percentile points higher than your acceleration, we're going to call you strength dominant, right? And the implication there is you need to train acceleration, right? And to train acceleration, what you need to do is train at low resistances at high velocities to increase your rate of force production, right? If your acceleration is a lot higher than your power, then what we want to recommend then is to train moderate force at moderate velocities. So therefore, you're going to train power to improve your ability to generate more power with more speed. And if you're kind of at an even amount, so you have a good amount of power and acceleration, then we call that a balance of high strength and speed. Then what we recommend is a mix of speed training and power training. Okay. I don't know how I did that. Somehow I drew on that. So, all right. Are you guys seeing this red line on here? Yes. Okay. I have no idea. There we go. I somehow undid it. Great. Okay. So now, if we are kind of in this, so again, we're making the determination of how someone should train along this force velocity spectrum. So essentially, if they fall into the train strength classification, they're going to fall right here. We're going to say, we're going to give you an exercise selection. Just as an example, if it's a horizontal pushing movement, we're going to recommend they do something like a bench press, right? Well, if they fall in this kind of like middle area, they're in the speed dominant category, we're going to recommend they train power. So maybe we're looking at something like a ballistic push-up. And if they're in the strength dominant category, then they need to train speed. So we're going to recommend something like a med ball toss. Okay, so I think at this point, let's jump in and let me actually show you what this looks like. I have my screen set up to be set up just like it is on Proteus. So I'm going to log in first. And then after I log in, I'm going to pull up a session of an athlete that I've already done this on. But before I do that, I just want to first show you guys what these tests look like. How do you know which tests generate insights and recommendations? If you go into your performance testing area, anything that has this insights provided icon on it will provide insights for that particular test. So you'll see that these are all new tests. We just published them when we released this feature. They're a wide range of sports. A couple of them are even just things like our old tests, like the general power test, the Cressy performance test. Those are still on there, but will now also generate these insights and recommendations. And we also have the ability in the future for you guys to potentially make your own insights and recommendations generating tests. For now, though, they're just ones that we generate and publish to all the machines. So they're going to be in this Proteus ecosystem test area. And the main reason we're doing that is to kind of control for selecting exercises and movements that we have confidence will have high sample sizes so that we give you good recommendations. Now, obviously, that depends on the filter settings that you select, which we're about to cover. But for now, these are available for this. In the future, or for these tests, in the future, you'll be able to build your own tests that generate these as well. Reach out if you have any questions about that. Happy to talk about any other tests that you guys are interested in. You can email me or reach out to the human performance team, and we can try to get that set up for you. So if we're going to look at the actual history of a particular athlete, if you want to pull up their data to look at these insights and recommendations feature, just to kind of give you an idea of how to get to this, by the way, this is something I think a lot of people struggle with. If you log into your machine, the athlete you want to look at, and this you can do by the same way by going to client.proteusmotion.com. You log in, you select the athlete, you go to their history, to their dashboard, and you're going to tap this history button, and then you're going to select the test, the testing data, or the testing activity that you're interested in. So in this case, I'm going to pull up this baseball test. And this baseball test I actually did earlier today, so I can make sure we had some fresh results here. So this is actually me, in case anyone's wondering. I'm putting myself on blast here. So if we go to the Insights tab, right now, the way that we have this filtered is we have it filtered by, and this is the first thing you want to do, set the filters for the athlete you're working with. So this Alex athlete that we have this protocol that we've made for, we've kind of set this athlete as being a 20-year-old baseball player. This is kind of the typical athlete that we work with. So you'll see we have it set for males 20 to 30. right? And so I can change that though to be more specific. So if I care more about adding in their weight range, right? So I can see, how do they compare to a certain weight range? If that's something I care about, or maybe I care about, comparing them only to other people around their same height. So, if we're talking about, lever arms here for certain positions, you can come in and change that. And you can also select the sport, the position at the sport, and then even the skill level. So I'm going to just select baseball and college here, right? Just to add to these filters. I'm going to remove these other ones because they're not as relevant, right? So we're just going to say, how do I compare to male collegiate baseball players, right? And then now the insights and recommendations are going to customize to that specific group. So now when we look at this, you'll see that all my recommendations scale to that group, okay? So just for one more time, when we show you this, we're going to go in here, we're going to set the age range if that's something we're interested in. In this case, I'm just going to clear the sport just for the sake of showing something a little bit more simple. And you'll see that now these recommendations slightly change. So let's get into the actual meat and potatoes of this, looking at the visual. The way this works is when you do this particular assessment, this is a baseball test. It has a push and pull exercise, trunk rotation, plyo trunk rotation, PNFs, and lateral bounds. Okay, so then we take each of those movements and we put them in what we call a movement category, right? So a lower body lateral push, that would be the lateral bounds, right? Makes sense. Upper body horizontal push, that would be your push and pull movements on the machine. Then you have your diagonal push and pull, that is your PNFs, and you have core rotation in there as well, okay? And then we take those and we look at, compared to this cohort, how does your power and your acceleration rank against that group in a percentile manner? So let's start with lower body lateral push. The power is the outer ring. The inner ring is acceleration. So if you look at that, if the outer ring is power, you'll see I'm 34th percentile compared to males in their 20 to 30. So because of that, I'm going to be automatically put into low strength because that number, that outer ring, was below the 50th percentile. So for that particular set of that particular movement or anything that falls into this category, I'm going to be recommended, if I go down the recommendation section, to do high resistance, low velocity movements, right? So for a lower body lateral push, what does that look like? What type of exercises would those be? Those would be lateral split squats, lateral sled drags, crossover lunges, anything that you can load a lateral push on. That's what we're recommending this person do. But this is something where you'd want to do heavier loads, right? But in those movement patterns, right? But now let's go back up. Now we look at the upper body horizontal push. That's the next one on the list, and the upper body horizontal pull. Those are the next ones that fall into the speed dominant category. So speed dominant means the inner ring is higher than the outer ring. So if the inner ring is higher than the outer ring, that means their acceleration was higher than their power. So what do they need to improve? Their power. So to improve power, what do you want to do? Moderate resistances explosively at high resistances. So for those movement categories, we go down to the speed dominant area in the recommendations, and you'll see we actually have recommended exercise selection for those particular movement patterns, okay? And then kind of the next visual, or the next couple here, we have strength dominant. So again, this now goes the opposite way. The power is higher than their acceleration. So in this case, power's more, a lot higher than their acceleration. So therefore they're stronger than they are fast. And then we are then going to recommend they need to work on their acceleration. So what type of exercise and load would you want to do? You'd want to do high speeds at low resistances, right? So you can work on rate of force development, getting out of the hole quickly with light resistances. And here are the type of exercises we can do for those particular movements, okay? And then the last one is balance. So for this group, you're just going to get a little bit of things that would fall into this category and this category for the green. So in general, what do we want to tell our athletes? When they do this test, after setting this to the right filter for that particular person, what you want to say is we want to move this visual. We want to move everything to the right. We want to move everything to the green. Green is good, right? So we want to get everything as far as we can to the green, and we want to fill these dials. The higher you are in these dials, the more full these dials are, the higher your percentile rank for these movement categories, right? And our recommendation is if you do the exercises here, you will improve those percentile rankings and you will move these things to the right. And so you can use this as a starter for a way to build your programs. Right now, obviously, you guys don't have to follow these exactly. You can, incorporate any type of training you want, but these are the type of things that we recommend. So just as another kind of new feature that we added here, we often had people with the Cressy tests or general power report want to switch between the last session and the new session really quickly. Well, we have that built in now. So if you go to change session, you can now view an old session and you can see how they compare instantly. So you can see when we did this back in, it looks like end of October. Actually on Halloween, then you can see everything got classified as low strength. And then if we kind of move to here, now everything's kind of moved, some things have moved up, some things haven't, right? In addition to looking at progress there, you can also look at the progress for each category by going down and tapping on this card. So see, when I tap on the card, you see a drop down and you can see how things have been changing in power or acceleration. In this case, power went up, acceleration went down, right? But you can do that with every single movement category if you're interested. The other thing that you'll notice here, and I'm just going to close these to make it easier to see, is we flag if you have a power imbalance. So anytime you do an exercise on the left and the right side at this, if you do the same exercise on the left and the right, we look at that and we see, okay, how does your power balance left to right look? If it's higher than 5 percentile points difference, then we call that out. So in this case, on the lateral push, 11% stronger on my right side. So that means my left side's 11% weaker. So the kind of suggestion there, if you kind of read the text, is work on the left side a little bit more to improve that imbalance, right? If you actually want to look at those imbalances more directly, we still have the historical bilateral balance screen so that you can select this and really look at how big the imbalances are for each particular movement. So that hasn't gone away. You still have that as a resource there. But it's at least flagged anytime we consider it a problem, quote unquote. And all we're calling out is a problem. Especially I know some of my fellow PRI people know that I believe asymmetry is normal, but too much asymmetry is bad. So we're basically only calling it out if you're above 5 percentile points. I would say anything above 10 percentile points, that's something you want to definitely address. Another thing that you'll see on this section is this particular test, the baseball test. We did a kind of a regular static start trunk rotation, and then we also did a plyometric or a counter movement trunk rotation. So a trunk rotation, the first one is kind of the standard one where you start on one side, you rotate, pause, right? Versus the counter movement trunk rotation, you start in the middle and you do a quick load phase and then rotate, right? So we're really looking at the rotation after you get that initial kickback. And the thing that you should see is the plyo trunk rotation should be about 10 percentile points higher than the static start. If it's not 10% higher, we're going to give you a flag that we call low, basically a low elasticity flag. And the implication there is that you're not producing, you should be producing a lot more power when you do that counter movement, because you should be getting free elastic recoil from the fascia. You should be recruiting more muscles with the stretch reflex. So you should be getting a lot more power when you do that load phase. If you do not, then that means you need to work on that property, right? That amortization phase, improving that, if you think of the triphasic training, we need to work on that. So what do you need to do? You need to work on adding some plyometrics into your program, and we will call that out. So in this case, I was only 5% stronger or more powerful when I did that plyometric movement. So it's going to recommend we do some plyometric exercises in order to improve that. Okay, so that's going to kind of be everything, all the main things on this page. The only other tip I want to give you guys is what happens if you select or you have an athlete that has kind of a lower sample size. So if we get really, really specific or get into some age ranges or something where we don't have a lot of data. So let's say I were to pick something kind of obscure here, like baseball players, in their 40s. Like we just not going to have a lot of data there. So you're going to see this little warning pop up. And then you'll see that if I actually hit apply, some of these, well, actually, in this case, we still managed to have enough data. Let me get more specific. Let me get to like baseball pitchers and hit apply there. Yeah, so you'll see now some of the exercises don't have enough data to actually create a recommendation. So even though you did a lot more, we're only going to show the ones we have enough data for. And then everything else we're going to kind of put into what we call like an unclassified movement category because we don't have enough data to actually back that up. If you want to, so the recommendation, by the way, is just to remove these filters, right? You want to go in here and say, you know what, this, let's get the most drilled down filter that we can that makes sense for the athlete we're working with. Let's remove pitcher. And let's remove, 40 to 65. Obviously, now we have much more information on just male baseball players, right? So there's a tip there. You are going to run into some situations right now while the database is still growing, where we're not going to have data for even some, kind of athletes you'd expect. So with a lot of female athletes, we're still growing that database for certain sports. Certain sports we have tons, certain ones we don't. So just get down to the filter that makes the most sense. Our database is growing at 10% per month. And I actually think that was the last time I checked. It might actually be higher than that. And the more you guys fill out this data and put in the users' data, the better that database is going to be. So let me take you to one other screen real quick, which is the test results screen. So remember, when we first land from a test, this is the screen we actually land on. And this screen will show you, compared to the last time this client did this particular test, then you'll actually be able to see how they've progressed in their overall power. So that averages the power for everything you did, and then takes the average of all your acceleration, and it actually shows you, what your progress has been from the last test to the current test, right? So you can actually look at that on the screen, see what that progress has been, and you can see your percentile ranking for your overall progression. So overall, I'm in the 60th percentile for power, 52nd for acceleration, 84th percentile for Proteus score, and then you can look and see, what my overall power balance is, right? In addition, you can also drop down, and this is what we used to have in our on a different screen that we called comparisons, where you can actually go down and you can look at each individual exercise. And from here, you can do things like tap on the actual card of the movement. And if you tap on the movement, you'll see the sample size for the population that we selected. So if you add more filters, you'll obviously see these sample sizes drop. So you'll be able to actually know how confident you guys can be in building recommendations off of this particular, for this particular athlete at this movement. You also see the percentile ranking for that movement, for power and acceleration. Before we had our Proteus scores was this column. So now we're doing power and acceleration. And you can also see the mean and a few other data points. And also, this is how you access the 3D movement maps. That is now moved to here. So for any movement you're interested in, if you want to look at the 3D map, you tap on 3D movement, right? And then you can see that map in space. You can add all the reps, right? So you can look at other reps in that same analysis. And you can also look on the analysis screen to look at other metrics like deceleration, consistency, velocity, all these things. So probably not going to be used by a lot of individuals, but I just want to show you guys where to access that information. So like I said, the only other thing to kind of keep in mind is we will be adding a share button. It'll pop up right around here in a few weeks. And that'll then basically be able to send a mobile view of this exact same, exact same information that athletes can pull up on their phones, or doctors, coaches, parents, whoever you want to send it to. You'll be able to send it directly to them. So just to kind of wrap up here and kind of drive home a couple more points, the importance of what we're able to unlock here and the type of information we're starting to gather. Now, some of you guys might have seen we did a podcast on this where we dove deep into this information. We actually applied this logic of these how we bucketized people into low strength, speed dominant, strength dominant, etc. And looked at our historic data to kind of see how it ranked people. So just to kind of bring home to everyone what we found. We found some really, really interesting things. We found that in general, strength really needs to be evaluated as being under-evaluated in multiplanar movements. We see that power is declining almost 10% per 10 years of age. So for those of you that are working with aging population, we're seeing that our data backs up what's been done in isokinetic research and other research that shows that power decreases roughly 10% per age, but luckily that is very, very trainable. We're also seeing kind of norms around core strength. We're seeing norms around kind of overall where do people fall into the overall strength velocity curve. And you'll actually see that roughly 56% of the people that we looked at who performed the Cressy performance test fall into this kind of low strength category. But more importantly, we'll see that about 23% are falling into the category of training speed. Like they have enough power and they're not able to use the strength that they possess. They're not fast enough to use all that strength, and they need to be training more speed. So I think this group in particular is being underserved. And what we really need to do is improve our ability to personalize these programs, right? And to do that, we have to test all planes of movement, right? And we have to compare them to the norm for their age, sex, and sport. And we have to understand where an individual puts them on, individual's performance puts them on the force velocity curve. And so looking at that data just visually, you can actually see that if we kind of slice and dice it here, basically, if you're above that baseline strength, 51% of the individuals that possess baseline strength, right, need to be training speed. 26% need to be training power. So, and what it really means is 77% of people that we've tested overall, or 77% of these individuals have an imbalance of some kind between power and acceleration. So knowing this information is going to help you to dial in exactly what they need. But more importantly, you can even look at different areas of the body. And I thought this information was really interesting. We dove in a lot deeper with Eric on the podcast, but we found that in general, the core was no matter how we slice the data, is the weakest area or weakest region of the body, particularly rotational core movements. And that's likely because it's a very difficult exercise and movement pattern to load and to test normally. You're also going to see, if you look at different planes, if you look at sagittal plane movements versus frontal and transverse or triplanar movements, you'll see that sagittal plane has it's way fewer people fall into the strength deficient category. A lot more people are strength dominant. And so, kind of the inverse of that is if you look at triplanar or frontal and rotational plane movements, a lot more of those movements need to be training baseline strength and improve power production. And, if you're only testing things in the sagittal plane, you're really missing the whole picture. And so really what we're trying to drive home here is that individualization matters. You don't want to train someone or a movement pattern here if what they really need is here, right? And you don't want to train someone here if what they really need is here. Now, you're probably not going to do too much harm, mixing things around, but if you really want to dial it in, then having this data will help you dial in exactly what they need so their test or their training is way more efficient. And we actually have seen that if you apply this logic, so if you are like Cressy Sports Performance, a place that pays a lot of attention to the force velocity curve and trains along the entire spectrum, if you train all these multiplanar movements across the force velocity spectrum, you see positive changes in the athletes' profiles by the end of the training season. So we saw that happen. We saw these athletes get faster, get more powerful, and get stronger when they did that. So kind of the last thing, and then I want to open it up to questions here at the end. Want to give a few recommendations on how to do this, right? How to implement this testing. Probably the best thing that you can do is at the beginning of a training program with an athlete, select one of these, what we call like a main test from that main screen that is an insights and recommendations generating test. So in this case, I selected the baseball test. It's only going to take you 5 minutes to run through this test, right? And this particular test looks at PNFs, push-pulls, trunk rotations, plyo trunk rotations, lateral bounds. You want to do that test. And if it's their first time ever using Proteus, to make their their testing more accurate, you want to probably do a throwaway test before that, just to teach them how to do the testing protocol and so that they know how to go at full effort. So we actually have a practice test that's published on there. You can always do that, or you can have them do the first couple of exercises or the first set of the first movement and just restart it before they finish their test. So that is an option. But do something to help them learn how to go at max effort. Then every 1 to 2 weeks, we recommend doing a shorter version kind of checkup on some of these same movements. So think about doing a quick baseball test that looks at, say, just push-pull, trunk rotation, and lateral bounds. Something like that will give you an idea of where you need to train or kind of how things are going without going through this longer form test. And then lastly, we recommend you want to retest this main test every 4 weeks or so. And that's because power is very fluid and it's going to be impacted by this training very easily. And so the recommendations kind of expire. We actually throw up a warning on the screen if it's been longer than 4 weeks, because we don't have confidence that those recommendations are valid after about 4 weeks of time. So retest. That's really important. I come from the PT world where we have to measure things all the time. It's really easy, and what you're going to find is it's going to keep you honest. It's going to keep your client honest, and you're really going to be able to see how those things are progressing a lot more easily and kind of where you want to change things. And what's really cool, we've seen this already since the feature launch. Seeing that progress from session to session is really motivating. Right? So do that, is make sure you get those retests in, try to do it every 4 weeks or so. And I think you're going to have the best outcomes. So yeah, so that's it. I want to kind of take a pause here and actually, take some questions. So anyone that has questions, feel free to jump in. I'm also going to check the chat here and look and see if there's anything there. But before I do that, any questions from the audience? All right, so nothing yet. So I'm going to answer one of these, a couple of these questions in the chat. So yes, Juan Pablo asks, is there a way to see what sample size is for a given cohort group? Am I being compared to 500 athletes or 5? And so the answer to that question is yes. So if you might recall, and this, what you want to do is for any particular test, you want to go into the actual screen on the test results screen. Hold on 1 second. Let me pull up the right screen here. You want to go to the test results screen, and then you're going to pull up the actual. Let's see. Are you guys seeing my screen here? Yeah, okay, cool. So you're going to pull up this test results screen. I'm going to open this. And you want to go, just to kind of remind everyone where to go. So if we go to this athlete, we select history. And
Will,
then,
you're still on your PowerPoint.
thanks, man. Appreciate it. All right. I got too many windows here. Justin knows I open too many windows all the time. So let's see here. All right, 1 second. Well, I lost it. So I don't know which screen I'm on. So give me 1 second. But what you're going to do is go to the test results screen, and you're going to pull up the, click on the card for the exercise that you want to see. And then it's going to be right there. It's going to be on that particular screen. So any other questions? Let's see. Oh, here we go. I got it pulled up now. So if we go into history, go to any particular movement, and we then going to go down to the movement. You'll see for right here, horizontal row, there are 2,000 people, 2,000 males between 20 to 30 years old who have done this test at 12 pounds. So that's how you want to see that. That's the quickest way to jump into that information. Okay. And there was another question, looks like around why we chose 5 percentile points as the difference between power and acceleration. A lot of this was done based on some conversations with Eric Cressy and a few other individuals. And essentially, when you get above that number, it's more of a situation where you want to stay balanced. Remember, when we're working on someone's ability to move across the force velocity spectrum, you can see that the way to think about it, if we kind of go back to actually this graph right here. Sorry, 1 second. Let's pull the right one up here. Of course, I got the wrong one up on this screen. Just give me 1 second. You want to keep things balanced, right? So when you're training along the force velocity curve, right, what you want to do is not have this situation happen. So if your power is a lot higher than your acceleration, right, then that means kind of the middle of this curve is kind of potentially a lot, starting to, develop or improve. So you're getting improvement here, but not necessarily down here. So what we want to do is then balance that out by doing a little bit more acceleration work, right? And the 5 percentage points or percentile points difference is a way to just indicate that imbalance between those areas. So if you're seeing kind of in that green zone, that means you're kind of, what you're doing is you're achieving this right here. You're improving the ability to move the curve on all parts of the spectrum rather than at any single point. Versus if you see that imbalance, that means that's giving an indication that, say, the acceleration, let's say the acceleration is a lot higher than your power, that would look like this line moving up, but not moving up right here, right? So we just want to develop kind of the whole full spectrum and not focus, our goal is to move the entire curve, not one part of the curve. Okay. So any other questions? All right. Well, I'll pause here for 1 more second. If you guys have any other questions, feel free to email me. It's will@proteusmotion.com. A lot of you guys have my phone number. Feel free to reach out there, call, text. I'm always down to hear from you guys. And otherwise, enjoy the new feature. Please, share your feedback. Let us know what you think. And, we hope you get a lot out of it. We've been working on this for quite a long time. And we're really excited to get that out here. Feedback's been great so far, but we're always looking to improve. So please don't be shy and let us know. All right, everyone, y'all take care. Have a good one.